how do we solve the initial value problem? For instance, you are given this question to show that this function is a solution to the initial value problem, and you're given the PDE and the initial condition. So let's find out. To solve this, we need two simple steps. Number one, we need to identify the following. The PDE, we need to also to identify the initial condition, and number three, the proposed solution. Step number two, we need to verify the PDE. We verify the initial condition using the proposed solution. And if the proposed solution satisfies that verification, it becomes the solution to the initial value problem. As simple as that. So let's get into it. Now, the PDE is already given, that is ux plus uy plus 2u is equals to 0. The initial conditions are also given. I mean that it is 1, so u x 0 is equals to sin x. And the proposed solution, which is now the function that is also in the question. Let's now go to verification. So to verify that PDE, one, we need to find ux, that is the partial differential of u with respect to x, and the partial differential of u with respect to y. Now let's find ux, which is the same as du over dx, but remember, we are talking about partial differentials, okay? So if you find the partial differential of u with respect to x of our proposed equation, that is u e power negative 2y sin x minus y. Now let's find the partial derivative. Now if you look closely, we have e raised to power negative 2y, which doesn't contain x. Remember, we are differentiating with respect to x. So we can term that as a constant and extract it outside. So it becomes e negative 2y. Then now we find the partial derivative of sin x minus y. If you recall calculus, we said that the derivative of cos x is negative sin x, then you multiply by the derivative of the function of cos, okay? You also say the derivative of sin x is cos x multiplied by the derivative of the function of x. Now, if you look at sine, we have sin x minus y. So what is going to be the partial derivative? It's going to be cos x minus y, but we multiply by the derivative of the function of sin x minus y, meaning you're going to find the derivative of x minus y. And since we are differentiating partially with respect to x, you're going to get 1, okay? And I hope that's clear. So now ux of the partial differential of u with respect to x becomes e raised to power negative 2y cos x minus y. That's clear. So the next part is the uy, that is partial differential of u with respect to y, that is du over dy. We have e raised to power negative 2y sin x minus y. Now, recall the product rule. If you have two functions that have the same variables or something like that, so the product rule formula is, if you take the first function derivative, you multiply by the other function without making the derivative, plus now the opposite. The first one, that is u without the derivative, and v, you find the derivative. So in our case, let us make u to become e negative 2y and v to become sin x minus y. So what is the derivative of u? The derivative of u, if you recall again the chain rule in calculus, the derivative of exponentials is the exponential itself, you multiply by the derivative of its power. I hope you recall that. So the derivative of e power negative 2y is going to be e negative 2y multiplied by negative 2. That is negative 2, we have gotten it from the derivative of negative 2y with respect to y. Then now we put sin x minus y plus. Now the other equation, u becomes, you take as it is, but v you find the derivative. So what is the derivative of sin x minus y? The chain rule that we used earlier. So it's going to be cos x minus y multiplied by the derivative of the function of a sine, that becomes negative 1, because we are finding the derivatives with respect to y, the partial derivatives with respect to y. So now it becomes negative 1. So now the final equation should be negative 2y e raised to negative 2y sine x minus y minus, you see this, the negative here that we found as the derivative of x minus y with respect to, partially with respect to y. If now you place it, because of this positive, it should be negative e raised to negative 2y cos x minus y. So now, finally, we can substitute on the PDE and we see if it is going to be correct. Now, the value of ux is e raised to negative 2y cos x minus y, then plus uy, which we have just found here. So if you replace it and substitute, you're going to get that this function here and this, they cancels out. This function here and this cancels out. So that makes, that verifies our PDE. Yeah. That the initial condition is satisfied. Now, this is how we conclude. We conclude that since the solution, that proposed solution in our question, satisfies both the PDE and the initial condition, which we have verified, then it is a solution to the initial value problem. And that's how you solve that question. Thank you.